Welcome everyone. Yeah, today is our second day of hand tackling sets, and today we'll be looking at set reduction. Set reduction is method that we are going to use, an operation that will be, or let's say a concept that we use on set consciously and unconsciously to simplify stuff for us. In our previous video where we introduced set, we talk about set trying to find the root of which number was raised to a particular power. For example, if you are looking at the number that was squared to find maybe 36, you need to find the square root of 36. So trying to find the root square of 36 is just basically finding that number that was squared before getting the 36. So we are trying to find going back to the root squared, the root squared. Yeah, that's basically the meaning, and we explored that in the previous video where we also said for prime numbers, when we find the square root of a prime number, we are not going to have a whole number. The main idea about set is that if you use set on a number, right, the result that you get should be a whole number, like 3, 4, 5. It shouldn't be 4.2, 4.1, 4.3, 4.9, and things. So yeah, basically that's the basic underlining thing. But finding finding the square root of prime numbers is not going to give you a whole number. For example, square root of 13 is not going to give you that a whole number. So there's going to be still be a fraction component. So those numbers that if you find the root of them, they are roots, they are square roots, and you are not getting a whole number, right? They are sets. They are sets. So we said that in the previous video. Now, so when numbers are perfect squares, when numbers are also perfect squares, you also agree that find the perfect square, find the square root of perfect square, we just give you the basic numbers. For example, as we have it on our board here, we have 1 squared is equal to 1, 2 squared is equal to 4, like all the way to 10. We are going to stop at 10 just for the illustration. Square root of 4, which we have here, square root of 4, if you find the square root of 4, the root is going to be 2. Yeah, the root is going to be 2. If you square root of 49, the root is going to be 7. So if you have a number, right, for perfect squares, it's easy to go back and find them. But then let's look at other numbers that may not be prime numbers, or they may not be perfect squares. For example, trying to find the square root of 24. Square root of 24, right? 24 is not a prime number. 24 is not a perfect square number. So how do we tackle this issue? So to tackle this issue, you have to do something we call set reduction. You need to reduce the number. So let's say we are talking about 24, right? So let's reduce the number. So reducing the number means look for the pair of numbers, right, that multiply to give you the 24. Look for the pair of numbers that multiply to give you the 34. I'm coming. Yeah, so sorry for that. So let's look for the pair of numbers that multiply to give us the 34. So there are what two numbers can we have to find 24, right? So we can have, let's say, 3 times 8. 3 times 8 give us 24. Another number. So 2 times 12, like the basic one. 2 times 12, that should be the first thing you should think of. And what another pair of number multiply? I think 4 times 6, right? Yeah. Someone will say 24 times 1. If you do 24 times 1, you're still going to get 24. And you're trying to break down 24. We don't want to see 24 itself in the pair of numbers we are breaking it into. That's the idea. So 24 times 1 will not be something that will qualify for the set reduction. So now we are trying to reduce the number 3 times 8 to give us 24. Other options are 2 by 12 and 4 by 6. Yeah, for 24, that's it. But then since all of them give us the same 24, we need to choose just a pair. We only want a pair of them, not all of them chosen. So which pair are we going to use? Now, this is where you have to be careful. The pair that you choose, right? The pair that you choose should solely be dependent on, should only be dependent on the pair that contains a perfect square, at least one perfect square. Let's go back. So if you look at this side, right? I call it the perfect square table of our first 10 numbers. First 10 numbers, right? So um if you look at here, these are the basic perfect square. You can continue up to 20. Then for you to just take note of them. But then for the once you are going to surround ourselves around here. So you are going to see that um 3, right? 3 is a prime number. If it's a prime number, skip it. It doesn't qualify. 8 is not none of the results here in our um perfect square table. There's no result that give 8. So this pair, none of them is inside that. So we this pair is not going to be accepted. Now let's go to 2 times 12. 2 times 12. 2 is a prime number, right? So look at the answers. Don't look at the one number that was squared. No, look at the answers here, the side here. So look at that and say, oh. So let me even put maybe let's say a circle around it. Let me encircle this, put it in a loop for you. And we are looking at this, right? Because if you're able to find this in a number, you can easily trace back the root. Like, can easily trace, like 80. If you find 81 in the pair, then you can easily trace back the root that, oh, that's easy, is 9. So you look at the 2, right? 2 is not even none of these, and 2 is a prime number. So quickly, let's look at 12. 12 is none of this, so it doesn't qualify. So this pair doesn't qualify. And let's look at this pair. 4 times 6. We look at 4, right? 4 is here. 4 can easily be traced to 2 as the root. Yeah, fine. 6 is not there. So but in this pair, at least there is one perfect square. So this pair is valid. So our square root of 24 will now become square root of 4 times square root of 6, because that's the pair that we choose. We have selected. And we learn that square root of 4, right? When you look at the table, it's going to be 2. So 2 times root 6 cannot be, it's not in the table. But we also know that root 2, root 6, right? It's not a prime number, it's not a whole number. Can you try to reduce it? Someone would think like that. So let's try to reduce it. We don't want 6 times 1 because we are trying to bring down 6. So you have 2 times 3. That's the only option that's the pair of number that can multiply to give you 6. Yeah, multiply. We are not adding, multiply. So 2 times 3. That's the only one. And it end up that only prime number 2 and 3 are the prime numbers. They are both prime numbers, and they're going to give you the same 6. So they are contained prime numbers, and so they can not further be reduced. At the end of the day, we still keep this guy like as such, because if you reduce it, you are not going to have any perfect square number inside. So we still maintain our 2 square root of 6. But it's best to write it in this form: 2 root 6. 2 root 6 just means that we are multiplying. Just how you have x, right? We have 2x. So you can have 2x. So 2x, you can say is 2 times x. So you just write it as 2x just to make that they mean that. So that's how root also works. So you see a number multiplying a root like that. So there is 2 root 6. 2 root 6 is our final answer. So if you said reduction on square root of 24, you are supposed to have 2 root 6. Remember, we are focusing on positive square roots. If you watch our previous video, you understand why we are choosing that. So 2 root 6, we are taking only the positive square roots, right, in our scope. So watching the previous video will give you the knowledge, and I encourage you to all watch that to get an understanding. So you follow the concept. So you have to take a concept from there, connect it to these videos one and the ones to come. That's how. And then set is going to something that you are going to stay with you in your journey in mathematics from now on. So now that's about set, right? Let's now look at another example. Let's use another example. Like, that's not a prime number, that is not a perfect square, but we have to use reduction to reduce it on our own. We are going to focus on the simple numbers here, right? So that we can quickly maybe get the concept, how it works. Then we can escalate later. Let's say square root of 18. Square root of 18 is not a prime number. We agree it's not a prime number. And then we agree that it's not a perfect square. So we need to do reduction. So reduction, so we just focus on the number itself, not the root, the number itself. So what number can give multiply to give me? So I know that 3 times 6, right? 3 times 6, yeah, it will give me that. And 2 times 9 will also give me that. Those are the pair of numbers that give me 18. But if you look at this first one, right, 3 is a prime number. So yeah, it's kind of, it doesn't qualify. 6 6, you broke it from the previous one. If you break it, if 6 is not even a prime number, so this pair doesn't qualify. If you look at this pair, 2 is a prime number, so it doesn't go. The other number, remember 9. 9 is here. 9 is here. 9 is here. So you can see that 9 is traceable to 3. So 9, this pair qualify because there's at least one perfect square. So if there's at least one perfect square, what do? We now say that our root 18 is equal to this pair. So it's going to be root 2 times root 9. So what do I have? Root 2 is the prime number, so we keep as such. But square root of 9, we said is 3. Positive square root. Remember, we are focused on positive square root. So when you have that, the answer is now 3 root 2. So the whole numbers are always at the front. Just like how you have, it's just like you have x times 3. So you just basically write 3x. So it's best to put the numbers in front of the variable. It's here in front of the square root, right? So this is the answer for 8, square root of 18. But we cannot do the same thing for square root of 17. Why? Because 17 is a prime number. So if it's a prime number, the answer is square root of 17 again. So square root of 14, for example. So 14 is not a prime number. 14 is not a perfect square. What do? We try to break it down. So if we break it down, we realize that the only number is 2 times 7. 2 times 7. 2 is not a prime number. 7 is not a prime number. 7 is a prime number and 2 is a prime number. Sorry. 2 is a prime number and 7 is a prime number. Are we okay? So with that knowledge, what happened is that since all of them are prime number and there's no perfect square inside, it cannot further be reduced. So the answer still remains the same because there's no other pair again. 2 times 7, right? There's no other pair that can further reduce it. So square root of 14 is the same as square root of 14. Because if you do the reduction, you are still not going to get any perfect square inside. So we keep it as such. Then let's talk about square root of 28. Square root of 28 is, let's say, it's going to be, so let's reduce 2, right? Let's reduce the 28. That's 2 times 14. Or we can also have 4 times 7. Yeah, so yeah, there's no other number that, so these are the two pairs that we have. So now let me clean this space so that we can continue with our roots 28. Let's see. Yeah, so we said the 28 is broken down to have two pairs. The first pair is 2 times 14. The other pair is 4 times 7. So quickly we know that this is a prime number and is not even in the result here. And then 14 is not even 14 is not in the result here. So this pair doesn't go. 4 4 is a 4 is a one of the response over here, which is here. We can be traceable to 2. So we pick this pair. Once you found one perfect squares, continue. So now our square root of 28 will be equal to square root of 4 times square root of 7. Those are the pairs that we found. So at the end of the day, square root of 4, what did we say square root of 4 is? If you look at it, you can trace it with 2. So you have 2 times square root of 7. 7 is not even in the answer, so we keep it like that. Then we just nicely write it back like this, square root of 7. So this is the answer. This is the reduced form. So square root of 28 is the same as 2 root 7. Yeah, that's it about that. And that's how set reduction works. So let's sum up everything that we have learned. So in this video, we learned that so in the previous video, we learned that prime numbers and perfect square numbers, prime numbers, you know that the answers will be the same. And then, but for perfect square numbers, when you do that, when you find the square root of the perfect square numbers, right, you get back the roots. There's an existing root already. But when you have a number that's not a prime number or not a perfect square, you have to use set reduction. And then I want to do set reduction to say that find like pairs whose product whose product gives the number. Product means a multiplication. So if you multiply, the result of a multiplication is called the product. So find pairs whose product gives the number. Yeah, so among the pairs, among the pairs found, among the pairs found, among the pairs found, what do we do? Um, choose the one with at least at least one perfect square number. Perfect square number. Yeah. So then you simplify. Then you simplify. A basic example that from the video for what we did earlier, square root of 24. So step one, find a pair. This is not a prime number, it's not a perfect square. So we find a pair. So you know that 24 is the same as 3 times 6, which is the same as 3 times 8, which is the same as 4 times 6, which is the same as 2 times 12. That's the first step. We found the pairs. Now among the pairs, found the one with at least one perfect number. So there is no perfect square number here, so we cancel this one. 4 is a perfect. Once there's at least one, then we just pick that one. So square root of 24 will be equal to square root of 4 times square root of 6, which will give you square root of 4 is 2, and square root of 6. 6 is not a perfect square, it's not a prime. So we can let's now, after we are done, let's try to reduce 6. So we try to reduce 6 as well. So once it's not a prime number, it's not a perfect square, and then the square, try to reduce it and see. So if you reduce it, the only pair you have is 2 times 3, and 2 and 3 doesn't satisfy. There's no perfect square number inside. At the end of the day, we just leave it as such. So the answer is just 2 square root of 6. This is the result for 24, like following the steps. Then we just simplify them, and we say that the numbers, the numbers that are not under the square root, right, should be in front, and the square root number, the one that still remain in the square root at the end of the day, is attached to it as how we have written it. Yeah, this is the concept of using reduction, and then we have learned not just how to solve it, but we have learned when to use it and conditions to follow. So you have to check that the number is not a perfect square, it's not a prime number, then you can reduce it. That's when to start using it. And we remember in the previous video that perfect square numbers, right, they give you a whole number, but square root numbers, right, prime numbers, what do they do? They don't give you a whole number, they try to give you fraction. So those that still remain as fraction at the end of the day, they are the perfect sets. They are the one we actually call sets. Are we okay? Yeah, that's it for this video. So next time in next videos we are going to be focusing on addition and subtraction of sets. So if you have sets now, what are the various operations that you are mathematical, like addition, plus, minus, multiplication, division, and all that, and how do we apply them in solving problems? That's what we'll be doing next time. So next time it will be like addition and subtraction, and I hope that you guys will subscribe and follow us and get a click on the bell so that you can be having updates once we upload the video, so that you can quickly come and get the concepts critically and go and use it to make things simple for you. See you in the next video, and we are hoping that you support us by liking this video. Thank you very much.